Hello everyone, I am Debasis Misra and my next topic is confusion matrix. When I started learning machine learning, I thought accuracy was everything. If any model showed 90% accuracy, I assumed it was doing a great job. But as I went deeper, I realized something important. A model can be accurate and still make the wrong kinds of mistakes. That's when I came across the confusion matrix, and it's completely changed how evaluate classification model. This is the structure of confusion matrix. Let's discuss what is a confusion matrix. A confusion matrix is a table that help me understand how well my classification model is performing by comparing actual values with predicted value. The basic structure. For binary classification problem, the confusion matrix look like this. This shows the predicted value where predicted positive, predicted negative, and this rows actual value for positive and actual value for negative. The first row and the first column part shows true positive and next is false negative. This part shows the false positive and true negative. So what's the meaning of true positive, false negative? Let's discuss. True positive. The model predicts positive and it's actually positive. False positive. The model predicts positive but it's actually negative. False negative. The model predicts negative but it's actually positive. And true negative. The model predicts negative and it's actually negative. Matrices I calculated using confusion matrix. Once I understand TP, FP, Fn and Tn, I calculate useful matrices. First formula is accuracy. Here, accuracy tell me how often the model is correct overall. The formula is Tp plus Tn upon Tp plus Fp plus Fn plus Tn. The next formula is error, refers to incorrect prediction made by model. Formula is Fp plus Fn divided by Tp plus Fp plus Fn plus Tn. Or we can say that 1 minus A is equal to error. Precision. Out of all the time my model predicted positive, how many time was it actually right? It can be found by formula Tp upon Tp plus Fp. And the next formula is recall. Out of all the actual positive, how many did my model correctly identify? And the formula is Tp upon Fp plus Fn. And the formula of F1 is 2 cross P cross R divided by P plus R. Let's take an example of dog versus not dog, a confusion matrix out. In this example, we evaluate a binary classification model that predicts whether a image is dog or not. To implement confusion matrix, I imported some of the library files. Let's discuss here. NumPy is used to store actual and predicted label. This NumPy has NP. And confusion matrix help us to evaluate model performance. Skborn and Matplot are generally used for visualization. After that, I define the actual label and predicted label. I make one actual label, I make one predicted label, and I create one variable cm, and the row represent actual label and the column represent predicted label. When I print cm, we observe that actual dog is 4 and predicted not dog is 1. Actual not dog and predicted. So this part is basically a 4, 1, 1 and 3. The confusion matrix 4, comma 1 and 1, comma 3 confirms that the classifier correctly distinguishes between dog and not dog in most cases.